came up with this idea on making a conceptual video on how displacement, distance, speed, velocity, acceleration, time, how all that ties in, and how you can think of what's happening on graphs of motion. I'm going to begin by talking about distance and displacement. So distance is the length between 2 points. So suppose my house is 50 meters down the road. The distance from my car to my house is 50 meters. Suppose I go from my house to work and I go back to my house. My displacement is 0. Displacement is a measure of how far you are from your starting point, from your origin. If I was to go from my home to work and stay at work, then my displacement is not 0. It's, let's say, 15 k's. That's how far away it is from my home. So that's distance and that's displacement. There's no mysteries there. And distance is what's called a scalar in physics. Scalar means it's a number. It doesn't have any direction associated with it. Displacement, on the other hand, is a vector. And vectors are things which are numbers and they have direction as well. So suppose there's a wind coming in at, 10 k's per hour from the west. That's a vector. It's got it's a number with a direction. If I was to say 10 degrees Celsius, that's a scalar. If I was to say 10 kilograms, that's another scalar. If I was to say 10 newtons from the left, that's a vector. Once again, because it's got a direction with it. So that's distance and displacement. What about things like speed? So let's take off. Speed is a measure of how much distance you're covering in a certain amount of time. So I'm moving now, I'm looking down at my speedometer, it's reading 30 k's per hour. 30 k's per hour means I'm covering 30 kilometers every hour. And the formula for speed is very simple. It's speed, S, is distance D divided by time T. And speed can be measured in meters per second as well, not just kilometers per hour. If I put my foot down on the accelerator, my speed increases. I'm covering more distance over a certain amount of time. So that's speed, and speed is a scalar quantity. It's just a number. If I give speed a direction, if I'm moving, let's say 50 k's per hour here in suburbia, 50 k's per hour south, that's a vector. That's a velocity right there. So velocity is speed but with a direction. It's a vector. Then there's something called acceleration. Acceleration is the change in speed over time. It's how quickly your speed is changing. Put my foot down on the accelerator again. Right, I'm accelerating. And what's happening is, if you look out the window, it's a good reference point. When I accelerate, I'm covering more and more ground very rapidly. It's increasing, the distance is increasing non-linearly. That means it's not increasing steadily, it's increasing rapidly, like exponentially. So the formula for acceleration, A equals delta V over delta T. Delta, capital delta in Greek, means change in. It's used commonly in physics and maths. Think of temperature. Delta T for temperature, capital T, means the change in temperature. It's your final temperature minus your initial temperature. And delta T in the denominator for acceleration, this lowercase t, is the change in time. So final time minus initial time. And I'll show you acceleration once again. So here I'm stationary, right? I'm not moving at all. If I apply the accelerator, oops, there's the camera. It's going to show you outside the window once again as to what's happening. But I cover a lot of ground really rapidly, as I said before, in a very short amount of time. So if you look at, let's say, a distance displacement graph, if it looks like a trapezoid, so a trapezium like this, so a straight line, flat, and then a straight line back down, that's a displacement time graph. That's a graph showing me, that tells me what's happening throughout my day. So I start at home, I go to work, which is represented by that flat line. and I go back home again, and that's that line going back down again. If you look up one of my previous videos, that's what I talked about. That's the example I gave. And then the velocity time graph will look like a step graph. Okay, if I'm moving at constant speed, constant velocity, on that step graph, it'll be represented by a flat horizontal line. If I'm moving at 50 km per hour, it'll be a flat horizontal line. On the acceleration time graph, now if my velocity is increasing over time, the displacement time graph will look like a curve initially. Let's say at time 0, t equals 0, I put my foot down on the accelerator, I accelerate, the displacement time graph will show a curve, increasing exponentially. And that's because I'm accelerating. I'm covering a lot of ground very rapidly. I'm going to show you on this turn again, once again, when I turn. I accelerate up to 60 km per hour. What it looks like out the window. So out the window, if you're seeing me moving at constant speed, the frames should look pretty constant. They should be moving at a constant rate. However, if you're seeing outside the window that the views are changing really rapidly, I'm accelerating. Now, when I put my foot on the brakes, after I accelerate, I'm decelerating. That means that my velocity is approaching 0. My acceleration is approaching 0, I should say, and my velocity as well. I'm going to show you just right now on this road here as to what it looks like again. Acceleration. All right, here we go. So you probably would have noticed that the view outside was changing very rapidly. And so that's how you picture speed, distance, acceleration, velocity, and time. Okay, they're all related somehow, but just picture in terms of a car that's moving, and you should be able to interpret the graphs. Okay.